Hey people, thanks for tuning in today. The star of our show is going to be manganese. Today I'm going to be doing what's called the elephant toothpaste experiment, and this has been done to death on YouTube, or like James Corden did it on his TV show, and I think any science experiment that James Corden does, I would normally not do because I really don't like doing mainstream stuff. But I figured I had the potassium permanganate, so I thought I would change things up as always and try some things. So today I'm going to be changing up some of the components of the elephant toothpaste reaction. In particular, I'm going to change the surfactant that I'm going to use. Normally people just add like dish soap or something to it, and as oxygen is released in the reaction, this just immediately bubbles all that dish soap. You end up with like this thick column of soap that spills out everywhere, and your talk show host freaks out, and everyone thinks that all science is done that way, but that's not the case. But we're gonna have a really fun time. I just bought some potassium permanganate and some store-bought hydrogen peroxide. I think it's like 3%. And normally, the higher the concentration of H2O2 in water, the more reactive it is, because there's more of it around to react and then to produce more oxygen. So I got a bunch of liquids from around my house that I thought might be interesting just based on their macroscopic properties. So let's infuse them with oxygen and see what they do.
So first I add potassium permanganate to it, and we'll start with the basics here, just dish soap, to give us kind of an idea of how our hydrogen peroxide performs against kind of everybody else. I mean, if you're competing against James Corden, you have to compare, right? I made a whole thing about it, so I guess I have to. I had some hydrogen peroxide, and yep, look at that. That's awesome. So that's a column of soap that's just being bubbled, and the reason it's being bubbled is because gaseous oxygen is being infused into it, and that's just creating the most monstrous of bubbles. And at the bottom there, you can see that kind of reddish from the KMNO4. In this test, no surfactant. We're not going to add anything. We're just going to add straight hydrogen peroxide. Wow. So you'd notice the steam and oxygen coming off of that. There's a lot of heat being generated here, by the way. Next, I'll add 2% milk to our potassium permanganate. And I chose milk because it's also naturally a surfactant. That's why it helps to get rid of like spicy tastes in your mouth, because it dissolves the molecule much better than water ever could. So when I add hydrogen peroxide, then oh yeah, it foams, which is super cool because I've never seen this done. I've always kind of suspected this throughout my entire career as a scientist, but I never really got the chance to see if it actually happened. Next, I'll be working with vodka here, so a 21 and over type situation. In this case, I'll be using Svedka, which is a Swedish vodka. It's very cheap. I think it's okay, but this is not an alcohol review. This is science. We're very serious here. So I add hydrogen peroxide, and wow, yeah, it takes off. No surfactant needed. It just kind of escapes the test tube completely. Next, I wanted to try vegetable oil. It's a pretty viscous fluid, right? And of course, vegetable oil is not going to burn or anything. It's definitely not a surfactant, and it definitely does not dissolve potassium permanganate very well. So I'm going to give it a good stir in order to try and get everything in there. I don't know how successful I was at stirring it, but the word stir is in my name. And when I add the hydrogen peroxide, then it actually takes a second. You can see it kind of switching because of the hydrophobic nature of oil. It takes a little bit for the two water type layers to mix, and once they do mix, they do form that nice column of bubbles, which is really cool, right? So even though oil's not a surfactant, it's still, I think, viscous enough to perhaps give enough like tension, like water tension in this case, to push all that gas out. In the same boat, we got maple syrup, where in this case it's also a viscous fluid. It does contain quite a bit of sugar in it, so as some of you may know, the reaction of permanganate with sugar can be quite aggressive and exothermic, and so I was a bit nervous about this one, and it did start to react, I think, a little bit on its own, but it was generally pretty tame, which I was happy with. When I add the hydrogen peroxide, it actually is pretty weak, and I'm not entirely certain why, compared to vegetable oil, then this one is just kind of wimpy. At least it does reach the top, but it takes its sweet time. And I guess maple syrup is a bit more viscous, but I'm not quite sure at this point why that would slow it down this much. Kind of sad, and it's kind of weird to see maple syrup bubbling like that. It's not something I've ever seen. It's maple syrup acting like it's never acted before, and hopefully I really didn't want this to escape the test tube and go all over my bench with that nasty maple syrup. Next, looking at my Pinot Noir here, which is a wine. The wine I'm using is not particularly expensive, so I'm not bummed out. Wine, it definitely bubbled quite well in wine, which was also pretty surprising considering wine is not surfactant whatsoever. And I tried adding a bit more, and it eventually escaped the test tube and bubbled down, but that is some gross looking wine. Next, as you recall, my last experiment required gasoline, and so maybe a callback on this episode to my last YouTube video, so check that out if you haven't. But I don't add too much to the test tube, but when I add the hydrogen peroxide, it definitely bubbles. And I was a bit concerned here because gasoline's quite flammable, but everything ended up being okay. Next, Coca-Cola. Naturally a very good tasting product. This is not sponsored by Coca-Cola, but anyway, Coca-Cola, of course, is already fizzy, and it contains sugar, so I was interested firstly with its reaction with potassium permanganate, if it did at all, but thankfully it did not. And when we added the hydrogen peroxide, then it was proven to be, I think, assisted by its fizziness. So not only do you have oxygen gas dissolved in there, but you also have the carbon dioxide that's naturally in Coca-Cola. And I added more equivalents of hydrogen peroxide to see how much fizzing I could get, and I could get quite a bit. But don't give this toothpaste to your elephant if you have one. It'll just rot their teeth. And lastly, wasp spray. Definitely not something I had originally thought of, but as I was going along, it became apparent to me that this might be a good idea. So I did my best to spray wasp spray down into the bottom there, and it actually mixed. It actually mixed pretty well with the potassium permanganate once I got it all stirring. I guess they have similar solubilities, wasp spray and potassium permanganate. And when I add hydrogen peroxide, yeah, it forms a nice column of steaming oxygen. And that's it, everyone. Thank you so much for watching. If you're interested in more videos in the future, subscribe to me. I'll try to keep you entertained, and I'll see you next time.